In the previous video, I made a DIY CNC spindle out of a 540 RC buggy motor and an ER11 collet chuck, which worked out very well, except that this motor must be nearly 30 years old now and the brushes have worn out. So it is time to replace it with a new one. First, I will connect the old motor to a 7.2 volt battery pack to find out what the RPM is. It's around 12,500 RPM and it's pulling an out of focus 3.5 amps, which makes it about 25 watts. I found a new 540 55 turn buggy motor on eBay for about £8. I also found a motor cooler for a couple of pounds. I am going to use 3 0.1 microfarad capacitors with the small 104 printed on the side. First I tinned some wire and then I soldered them onto the motor terminals. Followed by a capacitor across the terminals and also between each terminal and the motor case to help stop interference. Time to disconnect and take apart the old motor support assembly. The black tube on the front is a marker pen holder. Installation of the new motor and rebuild the assembly. And reconnect the wires. And the heatsink. But the cheap cooling fan did not work. So, how fast is the new motor? Only 8,500 RPM. That's a little disappointing. It's pulling just over 1.2 amps, so that's only about 8.5 watts, not what I was hoping for. Well, let's try and cut a test PCB anyway. And another 0.8 carbide cutter bites the dust. Tiny, isn't it? We'll have to switch to plan B and increase the voltage by using a car battery charger as the power supply, which has a voltage of 11.25 on a normal charge and 12.4 on a fast charge. Just under 14,000 RPM at 11.25 volts and at 1.2 amps makes it approximately 13.5 watts. Jacking it up to 12.4 volts achieves almost 16,000 RPM and with about 1.2 amps means it's about 15 watts, so the new motor is a lot faster than the original but still uses less power. Running another PCB cutting test at the lower 11.25 volts and 13 something thousand RPM. I will be making a future video on engraving and drilling through-hole PCBs. This time it has completed the job without any breakages, so a success, I think. Here is the circuit board that finished without any problems, and also the one that failed next to it. And this is the one that has the components on it and will be a driver for an addressable LED strip using an AT-Tiny 85 microcontroller. If you've made it this far, well done. Please like and subscribe or have a look at my website. You can find the links in the description. I will catch you in my next video.